This is the Cloud Ace Podcast, bringing you the latest in cloud security through captivating chats with fascinating cybersecurity experts who are leaving their mark on the industry. Cloud Ace is brought to you by the SANS Institute and hosted by SANS certified instructor Brandon Evans. And now, prepare for departure. We are cleared for takeoff. And here's your captain, Brandon Evans.
Today on the pod, we have Josh Makinen, a brilliant cloud security expert who went from 0 to 700 miles per hour in just 6 years. After graduating with a degree in computer systems engineering and computer science from RPI, Josh started his career as a security consultant for the NCC Group, where he specialized in cloud, containerization, and web applications. Afterwards, I had the great pleasure of working with him at Zoom Video Communications, where he started in our security architecture group before transitioning to security testing. Today, he is a senior security architect at Snowflake, a company that provides a data cloud to unite siloed data, discover and securely share data, and execute diverse analytic workloads across multiple clouds and geographies. Josh has immense experience working as a cloud security engineer, architect, and DevOps professional. I am so excited to discuss how he got into the field, what he does today, and the turbulence he has navigated through the various cloud environments he has worked in. So without further ado, welcome, Josh.
Hey, good to be on. Good to talk to you again.
Awesome. First things first, anything I missed in the intro that you'd like to share?
Slight correction. I only had a minor in computer systems engineering. I was one class short, but that's it.
I'm sure you would have aced the major if you decided to go down that path.
But other than that, yeah, you did great. That is me and my accomplishments.
Awesome. So first and foremost, what made you decide that you wanted to specialize in cloud security?
It wasn't a very conscious choice at the time. When I started at NCC Group, when you start out as a consultant and you don't have a ton of experience, as I was coming out of college, you get assigned shadow work where you aren't actually getting billed to the customers and you're just kind of there to be gaining experience so that if you do enough shadow jobs, you can eventually do it on your own. And so during my first couple of months, I got assigned a couple of AWS configuration reviews, and NCC Group developed the tool Scout. At the time, it was called Scout 2, but Scout Suite now. And at the time, it only scanned AWS accounts, but you could run this, and it would make a bunch of API calls against your account and come back with all this information and kind of scan for some common misconfigurations and patterns that seemed sketchy. And so when I was starting, my job was just to take the outputs of that tool and kind of turn them into findings. We had some boilerplates, but the boilerplates weren't totally perfect. And so a lot of my cloud learning was trying to just copy and paste a boilerplate, finding out how horribly wrong it was for this context, and then just building up on that until I eventually became kind of de facto AWS person at NCC in the Seattle office. There were a lot of us out there that were good with cloud that I learned from.
Awesome. And Scout Suite is a huge tool for those that don't know. It's a great tool for scanning AWS, Azure, GCP, and more. We use it in Sec 510 actually to find instances in which our cloud environments are not meeting the Center for Internet Security, or CIS's, various cloud benchmarks. So it's awesome that you got to work with that as a part of your time with NCC. Now, this is a very general question, so you can take this wherever you want to go with it. But what are some of the biggest mistakes that you have seen cloud users making? Because I know you've worked in a lot of different environments, and you've probably noticed some patterns of things that organizations tend to do wrong.
I mean, I think a lot of times it comes down to what level of isolation you can get away with while still being scalable. Obviously, the easiest solution a lot of time is to just throw everything into one account and have everything on one EC2 instance and all of that. But finding out where it's important to be making those separations in execution environment and privileges, and finding out how we can enforce those boundaries, I think is the most general problem that people are facing, is finding out where those lines can be drawn.
Yes, and AWS makes this so difficult because they basically introduced AWS organizations so long into their cloud journey. And you need AWS organizations in order to feasibly manage multiple AWS accounts.
Yeah, there's a lot of organizations, like aspects of organizations that's kind of strapped on that doesn't let you do all the... It's not as powerful as a lot of people want it to be. Like, there's some pretty strict length limits on what policies can be for this thing called like SCPs. And that makes like a lot of recommendations you give around that just totally unworkable. You have to find ways around that because they strapped organizations on so late.
And for those who are not familiar, SCPs in this case are organization service control policies. They're a capability that allows you to set what different operations can happen within your AWS accounts in your AWS organization. But in comparison to Azure and GCP, which has had that kind of separation from the get-go, AWS is very inconvenient, certainly.
Yeah, and it's not just a security problem necessarily. It's like an availability and like reliability issue of if everything's in one account, then you could feasibly run a deployment that like locks down your whole account somehow, and that could be really scary. Or if one of your accounts is having some misconfiguration issue, the account level permissions really become an important building block.
Certainly. And here in security, we care about confidentiality, integrity, and availability. So if you're able to crash an application as a result of a bad policy, we certainly care about that.
Sure, totally. Yeah, I guess I meant less adversarial.
Certainly. Yeah, people can shoot themselves in the foot themselves. Absolutely. Now, really interesting about Josh, we talked about this a little bit offline, but I'm sure a lot of the listeners here are very familiar with supply chain attacks. Attackers are finding vulnerabilities in open source repositories, like we saw with Log4j. They are compromising repositories, like we saw with high-profile JavaScript libraries in late 2021. And what's wild to me is that in 2022, we've even seen some instances in which repository owners are attacking their own repositories to make a statement, such as when the author of Node IPC introduced malware into their own library in order to protest the war in Europe. Now, Josh here has created a tool that scans containers for certain types of dependencies in order to find these kinds of issues and compromises. Would you like to give us some more details about that project?
Yeah, so I don't know if that necessarily like scans the images. It's more of it's a tool to take advantage of a container image registry that you have compromised or that was misconfigured so that you can read from it. And the idea is that it can list out all the containers images that are on there, all the versions that exist, and downloads them all so that you can then process them with other things. I think the main purpose of it at the time was because I was seeing a lot of people putting secret, like sensitive information into the container images themselves rather than feeding them in at runtime. And when you do that, that sensitive data ends up in these container images that a lot of people are just putting in registries that aren't very well locked down and secured. And so it's kind of a post-exploitation tool in that way.
Got it. But in addition to scanning for secrets, it also looked at manifest files, which you could then use as an input into one of your software component analysis tools, right?
Yeah, to an extent. I mean, with the container image, you essentially have like the file system of the container. So you have all the information you need there to pass it into a scanner. In a container image, if we're thinking about adversarial, when you write the image, you can put whatever you want in the manifest and make like a malicious file system that doesn't have anything sketchy in the manifest. And really, the manifest might just say, like, I ran this shell script that was on the file system at the time, and you might not have the contents of that shell script. Actually, I'm not sure on that. That's specific. The idea is you can't really use it to reliably find, like, as a defense side tool there. I would rely on more, like, container image scanning dedicated tools technically this doesn't even like scan for secrets. It just like dumps it all out into like files that you can then scan through on your own. So it's just for dumping images out of a registry.
Got it. And for those who'd like to check out this repository, what's its name again?
I believe it's called Go Pillage Registries under the NCC Group GitHub organization. It has not been updated in quite some time, so your mileage may vary.
Certainly. So for those who are getting into cloud and they don't necessarily see the connection between what we're talking about here and cloud, containerization is such an important part of running cloud-based applications. And I know that you have an incredible amount of experience with containers and Kubernetes and other orchestration platforms. Would you like to help those who are just breaking into the cloud understand how these technologies relate to one another?
Yeah, so I kind of think of Kubernetes, a lot of people throw the term cloud native around, and I'm frankly not totally sure what it even means, and I don't think a lot of people do. But the way I kind of think of cloud native is it's technology that's not tied to a specific cloud, but is kind of, it is representing the way clouds tend to work. And so that means programmatic deployments and things like management interfaces where you can see the things that are running and the configurations of things. And so in that way, it's kind of a cloud in the way that you can request resources from this service to run as like infrastructure for an application. And so you can kind of interact with Kubernetes the way you would interact with a cloud. And as a result, a lot of clouds have implemented their own versions of Kubernetes. Like GCP has GKE, and AWS has EKS. I think, yeah, EKS.
Yeah, they've got like 12 different solutions. They've got...
Yeah, for different like container things, yeah. And so like containers are just like a building block of like, they're just a set of files that you can upload somewhere and ask them to be run. You don't get control over how they get run. The thing that's running them does. And so Kubernetes is just another thing that can run containers, and it does it in a scalable way that some people like the scheduling properties, and it's very modular. So you can customize it to however you need it to be if you put the effort in. So yeah, it's kind of a cloud, but not a cloud in the sense it's not necessarily running on not your hardware.
Awesome. Now, I've heard so many people talk about Kubernetes. I feel like people throw the word Kubernetes into a sentence just to sound like this is something special that they're working on. There's a lot of hype, it seems, around Kubernetes as a platform. Do you buy into the hype? Do you think it's actually really a great tool to use? And regardless of that, what do you think about it from the perspective of security specifically?
Yeah, so I think it's a very useful tool. I think it definitely gets misused in places. Like if you only have a single application you're running and it doesn't need to be able to scale and things like that, you probably don't need Kubernetes. But I think what it really helps with is this idea of shifting left and putting the responsibility of defining how your application's infrastructure looks and getting that into the hands of the developers, where they don't have to like stand up a host and understand all this host hardening stuff. That you can just kind of define a container, and the admins can be in control of making sure that the execution environment is safe. And so we can shift the responsibility of like deploying your app out to the developers in that way. So it's really helpful there. I think in doing so, you often run into this problem with security where just because there's bugs in this new thing doesn't mean that the new thing isn't helpful. So Kubernetes has introduced a whole bunch of ways that now, since we have this execution environment that's shared between different teams that might be deploying their apps, they now have this shared attack surface through Kubernetes and the hosts they're running on together, where they can kind of compromise each other. And so it really has been good for security in the sense that we have that manageability. We know where all these apps are and how they are getting deployed and what they look like, and we can apply policies to all of them. But you do get that attack surface between each other, and while there are ways to lock that down with things like gvisor and things to lock things down on the host level and making sure that no unrelated workloads run on the same node with like node isolation and like, I'm forgetting the terms for it, but where you can like do pod affinity and kind of dedicate a node to a particular namespace. So yeah, I think my take on it is there's absolutely a lot of ways Kubernetes can get abused. In the early days, it was really scary from security perspective. There was just an API server running on every host that every container could call into that would execute code on the host. So there was just horrifying conditions in early Kubernetes that I think have really soured some of the moods, and you really do need to keep up to date with the latest versions of Kubernetes because it being this big popular thing, there's a lot of really fancy, cool attacks on it that you might not get the latest update on.
Awesome. Well, I think beyond all the things that you mentioned with Kubernetes security being not necessarily consistent across the time it's existed, I think a lot of folks breaking into DevOps and DevSecOps are even scared about it as a concept. The idea of allowing developers to have so much control over how their applications are running and on what infrastructure, right? You mentioned how there are all these different misconfigurations can happen in terms of isolating these different pods from talking to each other. And traditionally, when we had development and operations would be responsible for hardening these environments, and the developers would focus on their application code itself. So I think there's a large debate about whether or not DevOps is good or bad for security. The idea of empowering people to own their own infrastructure. What's your take on that?
There's a few aspects to that. When you put that power into the developers' hands, of course, are going to be cases where it gets misused and where people write bad configurations and don't consider security how they're supposed to. But I think where security can come in to help there, in how we're doing it at Snowflake, is we have a very developer-driven security program here, where the developers are being empowered to be making these security design decisions and are kind of coming to us for advice on them. We have dedicated security partners on teams that are their whole job is to write threat models for these things as they're making. I guess not their whole job. They also work as developers, but their whole job as security partners is to be writing these threat models, doing risk assessments on all of these features and components as they come in, and making sure that they're getting the right security requirements in. And I think what's helpful there is the developers are going to know how their application works a lot better than the DevOps person will. And so if the DevOps person can focus on creating a secure execution environment, like a secured cluster where it's hard to shoot yourself in the foot with things like admission controller policies that stop dangerous configurations from even entering into the Kubernetes cluster in the first place. So you can write policies to try to make it as safe as possible, and you can add in these processes that make sure that the developers are considering all of the same things that a DevOps person would consider in the security of how they're configuring their infrastructure. And we can kind of leave the hard details of like, how do I write a setcomp policy that's secure again for this to DevOps, who can make more generic policies and open them up as they need to.
This is Eric Johnson, SANS Senior Instructor and Lead Author for Sec 540, Cloud Security and DevSecOps Automation. Building a security team that understands modern cloud security and DevSecOps practices is essential in the modern security landscape. If your organization is working in or transitioning to a public cloud environment, Sec 540, Cloud Security and DevSecOps Automation is the course for you. This course provides development, operations, and security professionals with a deep understanding of and hands-on experience with the DevOps methodology used to build and deliver cloud infrastructure and software. Students learn how to attack and then harden an entire DevOps workflow from version control to continuous integration to the workloads running in the cloud. Each step of the way, students explore the security controls, configuration, and tools required to improve the reliability, integrity, and security of an on-premise and cloud-hosted system. Learn how to implement more than 20 DevSecOps security controls to build, test, deploy, and monitor your cloud infrastructure and services. Learn more about the DevSecOps journey at sans.org/sec540. Thanks, and we hope to see you in a class soon.
Just out of curiosity, have you ever read The Phoenix Project?
Oh, that's on my list. I think that was one of the Zoom's recommended reading, right?
It's a great book on exactly what you're describing about how when you have a disconnect between development and operations, things can go wrong just the same as if you had people that focused on operations and hardening, because they don't have those requirements, right? It's a complete disconnect where you're throwing requirements over the wall or finished applications over the wall and people are not interacting. And the same concept is true for security. So if you're interested in DevSecOps, definitely a huge recommendation that people check out the Phoenix Project and the Unicorn Project. But Josh, you've lived it, so you're not going to learn a whole lot from it as far as I know.
Yeah, I think another place where that pattern comes in is in threat detection, because development teams aren't really capable of doing thorough threat detection, but the dedicated threat detection people don't have the full context on an app and what it's supposed to be doing that the development team will have to do. So that's one of those cases where you really do have to just have that collaboration happen rather than shifting it on to the developers.
Awesome. Now, from my experience, Josh, you are truly a change agent. You honestly care about doing things right. And that really dovetails into one of the topics I wanted to discuss with you, which is bureaucracy. It exists in every organization. It's inevitable. And I know that it can be very frustrating to deal with various blockers when you're trying to introduce security into an organization and really change the culture. So what kinds of blockers do you typically see both in your various jobs and in consulting when it comes to actually improving the security posture of your cloud architecture and applications?
Man, that's hard. I think having executive buy-in is really important, because you aren't going to get a lot done unless you can escalate to people and they can see the value in security just inherently and read your documentation that you wrote to make sure that you made your case and will make the right decision based off of that. And so I think a lot of it does come down to leadership. I unfortunately, I don't think I'm very good at the politics side of things as far as actually convincing people who don't want to care about security to care about security. But if we're on the same team and we're all saying let's make this the most ideal thing security wise, I can be a security evangelist in that way. I think the politics side of things is something I want to improve at. But so far the best patterns I've seen has been based in leadership.
Awesome. Well, I know that several security executives will be listening to this podcast. And I think that in a lot of organizations I've worked with, people really do care about security. They say security is a priority. They may even prioritize security over things like functionality. But still, there seems to be a disconnect where things don't end up getting done that need to be done. Are there any bits of information that you'd like to provide to executives about how to prioritize the right things and how to motivate the people under them to do the right things consistently?
Yeah. So I'll say this comes a lot down to the specific engineering teams a lot of the time. That the team and their priorities at the moment often dictate how they're going to be able to handle a security problem coming in. Oftentimes, it's hard because when I come in, a lot of times when I'm finding a lot of bugs, it's in a project that is being rushed through, and that's why you're finding all of these bugs. Or not even necessarily getting rushed through, but like just didn't go through all of the like steps of like, let's ask security for their take on this before we make it. And so I think getting in at the design level on these things, that's the cheapest place you can fix a bug, is by just not making the bug in the first place. And with design level decisions, you can stop a ton of bugs from ever happening and stop like a bad pattern from existing that creates new bugs. And so I think focusing on making sure that teams are considering the design of their product in how they're making their timelines and in getting security in early, I think is what helps a lot with getting those problems fixed. Because if you're coming in with this big launch blocking issue and they're trying to launch, you're going to end up playing the game of how little can we get away with and still launch. And that's not the right game to play.
Absolutely. And I think that's a big thing that a lot of executives miss in big organizations is you may be saying that, hey, security is a requirement. And if you're a CISO, you may be saying that and you will be getting backed up by the CEO. But people forget that there's so many different levels of hierarchy between the CEO and the people that are actually implementing the application design and building out the actual application, doing the coding. And there are so many different people that are coming to them saying, hey, you need to care about security. You need to care about this functionality. You need to care about getting this out on time. And there's a lot of conflicting priorities that are happening there. So people will end up taking the approach of cutting corners, like you mentioned. Now, you mentioned earlier about how you have embedded security experts in various teams there at Snowflake. And I'm wondering what cultural impact you have found has happened as a result of that introduction.
Yeah, I think it's been big. So I wasn't at Snowflake before we had this, so I can only say what I've heard and how I can compare it to other places that I've interacted with. But I think what it's done is a lot of developers do see security as being part of their job. And a lot of them, when they are getting to the point where like they are trying to release something that didn't have whatever design consideration, I am seeing more ownership of that and kind of people realizing like, okay, I need to involve security earlier next time. I've worked with teams with this that like we started out not on the same foot here. And I think a lot of what was happening there is that the thing had already it was pretty business critical. It had been through a lot of like discussions to determine that this was very valuable to the company to have this thing exist. But it just kind of wasn't that they weren't embedded in the security program, this team, before, because they aren't a normal development team. And so like this project started out as like one of their personal projects, and then it ended up getting cool. And so part of the problem was that they weren't, all this stuff that they'd already done had kind of been designed without security's input at all. And so we were just clashing constantly at first because this team is like, we care about security. We thought about all this stuff, but they didn't go to an expert to say like, this strategy actually secure? Am I going to have to redesign any of this? And so by getting them onboarded onto the program, I'm already getting like, I'm hearing about these things before they get written. I'm catching some scary designs, but like after that they've been through the threat model and risk assessment, that some stuff still gets through, but I was at least able to see that threat model so that I could go back and file a bug against it. And so I think it's helped organizationally in letting them be able to own the security, have a lifeline to the security team through like consultation tickets they can file with us. And yeah, I'm sorry, I just trailed off on that.
No, it's all very good input for sure.
I feel like we could probably cut all of that. I rambled hard on that part.
No, nah. Your expertise is more valuable than you give yourself credit for. Now, Josh has so much experience on the building and defending side, but I have to talk a little bit about the offensive side because that's, what I think is probably the coolest thing to talk about. And Josh has found some really interesting stuff in his experience doing offensive security. In fact, he found a vulnerability in an incredibly popular third-party dependency called Ansible, which is a configuration and infrastructure as code utility. And he found CVE 2021-3583, which was a high severity bug. So at a high level, what was that vulnerability about and how did it impact individuals that were administrating their cloud accounts using Ansible?
So I think it had the potential to be a bad bug in the right situation. I think practicality-wise, an attacker would have a hard time actually taking advantage of this. But what the problem was a classic template injection issue where an attacker's input ends up getting executed as a template somewhere. And since Ansible uses Jinja as its templating engine, I think Jinja 2 or something like that, it has different built-in functions that can essentially result in code execution or file access that I think they're called lookup functions in Ansible. And so I was able to take advantage of that template injection to run commands. So it's pretty specific, the scenario where this happens. It has to be an attacker-controlled variable getting used in YAML string that's using YAML's multi-line functionality. So it only impacted me on this personal project that I was working on because I was trying to pass template characters through a template to another template because I'm crazy. And I just kept getting weird bugs and realizing that my templates were getting double executed. And so, and just because I was using YAML multi-line strings in my Ansible roles. So it'll only affect you if you pass attacker controlled input into a YAML multi-line string, but I was doing it, and it would have let a host that I was interacting with off of my Ansible controller that's privileged. One of those hosts would be able to pass a variable, or they call them facts in Ansible, back up to my controller, and my controller would have executed it. And so if you think of this in the context of a production environment, maybe use Ansible to run apt update on all of your hosts on some schedule and just run upgrades or something. And if you do that, then, and you control one of these hosts that's getting that action run against it, or that role run against it, then you can pass up malicious values and get your code execution on a privileged host from, which might even be a developer machine. It might be a CI/CD worker that's running these things. But you can get privileged escalation through that.
I think you're underselling how significant this bug was, because for those who don't know, Ansible on GitHub has 53,000 stars. And if you've ever used GitHub, you know that a star is nothing. People do not star things often. So there's probably millions of users of Ansible. And people do wacky things all the time when you have developers who don't have the security expertise that you have. And if there's an exploit, which maybe would be rare, but if there was an exploit in this case, you could take over CI/CD. And your CI/CD instance not only has the ability to modify your various hosts, but they oftentimes have IAM permissions in your various cloud environments. You could theoretically, if you compromise that CI/CD, read all of the data in your cloud account, delete all of the data in your cloud account, and spin up random new machines to be a part of your botnet, or to crack passwords, or to mine Bitcoin on your dime. So, the probability might be low, but the criticality is just tremendous.
Yeah. And I think another aspect of that is if you get into the CI/CD, there's a possibility you might be able to push some bad code and do something even more subtle than that and have kind of a backdoored application deployed, or backdoored third-party dependency that you export to other people, and now you spread and you have your own supply chain attack.
Absolutely terrifying. I mean, if you think of, SolarWinds, the ability to administrate a network, now imagine being able to administrate all of the networks within your cloud accounts. It's wild.
Yeah. But from a purely practicality perspective of like an attacker trying to pull this attack off, you have to first control a production host, which is significant, but an assumption we tend to make on these kinds of scenarios. You would need to be able to know kind of what is going to get run against you. So you need to do some staking out to figure out when people are running things against you. You don't get to see the code of the Ansible role as it's going, so you don't even know where this multi-line string might pop up or what of your inputs might end up in it. So it'll probably be a little noisy, and that you'll probably make a few jobs fail trying to do it. But let's say you have access to the code that runs against you and you know where to do it, then you also have to hope that they're going to run that playbook against you. And so it would be hard to pull off, but if you pulled off, it would be pretty devastating. So yeah.
Absolutely. Sounds like one of the worst privilege escalation scenarios that could possibly happen. Well,
yeah, it's up there. Yeah.
Absolutely. Well, we're wrapping up. One last shotgun technical question, very open-ended question. AWS, Azure, GCP, best for security, worst for security, thoughts generally about these different platforms and how they differ from a security posture.
I have very little experience in Azure. I know enough for the general cloud things that you need to know, but I often need to ask people for context of what's the analog to this AWS concept or something. AWS is what I know the most about by far, just because that was a lot of our clients when I was consulting were AWS environments. So that's the environment that I feel most confident that I could secure. But GCP is what I use in my personal projects. I enjoy the management interface better. They got a more public bug bounty at the very least. Yeah, I think AWS, like we were saying, has also kind of gotten locked into a lot of design decisions that are hard to break out of. They were really early to get onto the metadata service, but that also means that they have this. They had to release version 2 of the metadata service and get it rolled out, and GCP and Azure may have gone through similar problems, but it has not been as significant from what I've heard. I think their version 1s may have had a little bit more protections there.
Azure's has better protections initially. GCP had a similar issue, but it wasn't as high profile because, for those who don't know at home, the instance metadata service version 1 in AWS resulted in a catastrophic breach you may have heard of in 2019. Maybe you've heard of the Capital One breach that happened over there. It largely had to do with the instance metadata service. So we have a lot of resources on SANS, a lot of public resources about the IMDS v1 if you'd like to learn more about that, or maybe we'll discuss it more on a future episode. But yeah, it's I definitely understand how AWS got locked into a lot of different design patterns being first to market for sure.
And I'm sure similar stuff happened to Azure. I just don't know about it as well because I think they're trying to lock in with being very compatible with older Windows infrastructure or domain controller type things. And Windows is a big blind spot for me technology wise, but even though I use it. But from what I've heard, there's a lot of hard things that are just kind of old legacy patterns that are hard to get away from for compatibility reasons.
Yes, and certainly they want to make sure that things work. I find that with a lot of cloud providers, they make things work by default and they require you to secure things because they know if they try to secure everything by default, it would break a bunch of stuff.
On the other hand, though, with GCP, you get the opposite problem of they will throw a service away without telling you. And it can be frustrating to be a GCP customer sometimes because the pattern does change pretty frequently, but because they're moving so fast and trying to make new design decisions as a result. So I think of GCP as being more bleeding edge security wise, potentially. I don't know.
Awesome. Well, Josh, if folks at home want to check out more of your work or follow you on social media, where can they find you?
So my handle is VMUTTI, VMuddy, but that's not what I am on Twitter. My Twitter is just Joshua Makinen. But if you want to find any of my other stuff, it's keybase.com/VMuddy. That's just my middle name with the letters switched around. Nothing special.
Very cool. And also now we have maybe one of your security questions answered as a result of knowing your full name. Maybe not.
No. Yeah, I have a blog, but right now it just has a write-up of that one Ansible CVE on it. I've got a few personal projects I keep meaning to make, but they aren't super security related. They're more about my development workspace and how I orchestrate all of that.
Well, we'll definitely have to check that out as you put up other publications, hopefully in the future. Man, thank you so much for joining us for this episode of Cloud Ace. I really appreciate getting to hear all of your experience as a cloud security engineer, architect, and a DevOps professional. And for those who are interested at home about these various topics, make sure to check out sans.org/cloud for a lot of free cloud security and DevOps tools, posters, cheat sheets, and more. And make sure to check out the job role flight plan to find out what courses make sense for you in order to get into the kind of field that you want to get into within cloud security, be it a cloud security analyst, engineer, architect, manager, or DevOps professional. But thank you so much, Josh, for attending this session. I really appreciate that you came here to share all of your awesome experience.
Awesome. Yeah, thank you so much. I've never gotten to be public speaking like this, but I listened to a ton of podcasts, so it was fun to be here. Thank you so much.